So in the previous lecture we have learned how we can assign offset and how we can assign releases. Now in this lecture I will teach you how to like fine tune this meshing, or how to proceed further with the plate system, or how to model the deck slab system. But before doing that, I will like you to please save as this model, because we will not use this plate in our final structure. I'm just sharing this just for your the introduction to how this plate meshing and deck slab system works. So either we can go to file and save as the structure, or what we can do is that we can copy this whole structure here. Let us select 10 meter. We need to select the plates cursor here also, and same procedure for Control C and Control V, and then left click on 10 meter. So we can like do the experimentation on this structure only, and if things go bad we can go back to the structure. So left click on plates cursor here. Now there are various ways with which we can like model this deck slab system. Either we can just delete this plate. Either we can go to geometry and composite deck system. So here we can see that this composite deck and create new deck option is coming. So we need to left click on create new deck. You need to left click here, and then left click here, and then again left click here, and then again left click here. So we can name this deck as composite deck D1. So now we can see that this composite deck system is now modeled here with this diagonal blue lines, and it is showing the various number of beams that are defining our deck slab system. So when we left click here you can see that this whole form will open. So if you are familiar to what are the parameters of the deck slab, all these systems will come here. So concrete thickness above fluids, so we can name it as, let us say, 0.075 or 75 mm. Unit weight of concrete, let us say 25. Concrete grade as 30 kilonewton per meter square. And now the rib properties, that is the deck slab that shall be installed here. So there is database also. That is, either we can go with these predefined rib property system. So let us say we go with Verco PLB. So automatically it is defining the rib width and rib height. Stud diameter is also very important system in this deck slab system. So either we can select the stud diameter as, let us say, 0.5 inches, and stud length is, let us say, 0.05 meter, and whether we can go with short system or unshored system. So we can left click on update deck property to save. So now we have understood how to model a composite deck slab system. Or this is this one approach. Or we can someone will want to say that he does not want this deck slab system on this structure shield members. He just want a RCC slab system. Or either we can assign the dead load of this RCC slab and analyze the structure. Or what we can do is that we need to go to geometry, plate. So here we can see that this plate cursor, plate number 54 is now available here. Or we can go to parametric models. So in the parametric models, save as this model again. So here we can see that this parametric model window will open. On the bottom there are various options, that is add, delete, merge mesh and remove mesh. So what we can do is that we can left click on add here, name as slab on steel, type as slab, and left click on OK. So here you can see that your cursor automatically changes. So what we need to do is that we can left click here and then select all these 4 joints. So this mesh parameters window will open. So we can either select it as basic meshing or standard meshing. Element type as quadrilateral, and divide boundary segments to optimize the mesh quality. Target element size we can select it as, let us say, 0.5. So we left click on OK. And do you want to add openings? We don't need to add on any openings right now, so we left click on no. So here you can see that the software is generated this meshing automatically. And if you will watch closely here, this is 0.5 meter and this is also 0.5 meter. So if we want to merge this meshing to our original like structural steel member arrangement, so we need to left click on merge mesh. So here we can see that the whole structure is now meshed. And why this whole thing is going up and down? Because we have added the specifications. So we need if we want to correct this structural steel arrangement, so we need to do the offset commands again. But this was just for an introduction to you that how we can go ahead with two approaches. That is, this is the deck slab system arrangement, and this is the plate system arrangement with meshing arrangement. So we have studied both of these arrangement, and I hope things are more clear to you. In general and specification, there is this plate system also. So in plate there is this command called plane stress command. So if we are doing the analysis like this in this arrangement, then we need to assign plane stress command to this plate. Otherwise the results may have some error cause of excessive stiffness along both the directions of this particular plate member. And if you study the various other specification of the plate members also, there are various other features. Either we can assign release to a particular joint of this plate member. For example, here we have joint number 1, 2, 3 and 4. So for example, if we are assuming that this particular joint does not have any moment taking capacity or force taking capacity, then we can assign release to this particular joint. Or either we can ignore the in-plane rotation, or we can ignore the stiffness also. Plane stress already we have assigned, and rigid in-plane rotation. So although it is not recommended to model this plate, as we have this command called diaphragm. So if we are assigning diaphragm to this particular floor, then we don't need to assign plate element also. So this is just I'm explaining all these things for your clarity only. And if we go to beam, there we have already learned how to assign releases, and we have learned how to assign the offset commands also. And one more thing that I'd like to explain here, that in release option, there is this option called partial moment release. So partial moment release is when we know that the only partial moment will travel through a particular joint connection. So in that case, we need to assign partial moment release. So how we can assign partial moment release? Either we can assign partial moment release along the local axis, that is MPX, MPY and MPZ, or we can assign partial moment release along all the three directions. I will always suggest you to go ahead with MPY and MPZ partial moment release, because this is the parameter that is much more actual. So let us say this particular beam column connection between this beam and this beam, only this 30% moment will get transferred and 70% moment will not get transferred. So here we can see that 0 for full moment restraint. That is, if we want a 100% efficient moment connection, we need to enter 0 here, and 1 for no moment restraint. And if we want a 100% shear connection, then we need to enter 1 only. But what if we want to this connection with only 30% moment taking capacity? Then we need to select 0.3. Cause the more we are going towards 1, the more we are going towards shear connection. The more we are coming towards 0, the more we are coming towards the moment connections. So we can select MPY and MPZ as 0.3 and select these beams here. So now we can be assured that only 30% moment will get transferred, and with this connection 100% moment will get transferred. And I am repeating here why we have not assigned this MPX, cause any moment along x-axis is torsion. And basically why I am saying this, that we'll study in the next lecture about the local axis concept.